This is a video on how to name acids and bases. So naming acids, if we know it's an acid, we know it's going to produce a hydrogen ion when it's dissolved in water. And there are acids that don't contain oxygen, and then we use the format of hydro, and then we plug in the anion like chlor for chlorine. So then so we're really just going hydro and then the anionic acid. This is for no oxygen in the compound. If the anion does contain oxygen, for example, this is, it's an acid. It has an ion, a polyatomic ion now because it has that oxygen. The polyatomic ion here is nitrate, and then what happens is we change the ending of the acid. So if the polyatomic ion ends in ate, then it becomes ic, I ate it, acid. And if it was ite, if the polyatomic ion, let's say you have sulfite, that's what SO3 is, then it becomes us, like arthritis. So anyways, based on that, then ate becomes ic. So this would be nitric acid, and then sulfite becomes us. So this would be sulfurous acid. And you can see I'm kind of adding in that and I don't really have a rule that you can always use for that. So if you were to just say sulfurous acid, I would be fine with that. So try naming these. I would pause the video, try them, and then see how you do. And then like this slide is the answers, but again, this was nitrate, so it became nitric. Notice I don't have any hydro in these, even though they have hydrogen. We only use hydro when it's an acid that doesn't have a polyatomic ion. It doesn't have oxygen. This is chlorate, perchlorate, so that's why it becomes perchloric. So these are ics because these were eights. And then this one here does not have oxygen, so this is the one where you get to use that hydro and the ic. And then this part is just going to be whatever anion this is. Writing the formulas for the acids, you just have to kind of reverse that thinking. So here, us came from ite. So I would look on my ion chart and find nitrite, and then I know it's an acid, so it's going to be with hydrogen, and then I have to balance charge, so this would just be HNO2. Here, this one is ic, so I know it came from acetate, which I can find on my polyatomic ion chart. Again, it's an acid, so don't forget the hydrogen. Then you look at the charge, balance it if needed. It's already in balance, so it'd just be this formula. So this is my answer, that's my answer. This is just my thought bubble. You don't have to show that work, but you have to think it. Carbonic acid, ic came from 8, so carbonate, and then hydrogen. This time to balance charge, you're going to need to have 2 hydrogens. So this would be H2CO3. This one has hydro in it. So I know all of these are acids. They're going to have hydrogen, but this means you only have the element nitrogen. Balanced charge, so it would be H3N. Naming bases is just like any other ionic compound. You just name the metal first, and if it needs, you use a Roman numeral. And then the OH is the hydroxide ion, and you just write the name hydroxide. So there aren't any more, the complicated ic goes to 8, those kind of tricks. You just name it. The only base that is named differently is ammonia, and it just doesn't follow any one of those systems. But ammonia is that really stinky cleaner. You find it in like the blue window sprays. There's just a teeny bit in there. You can buy it more pure. It's really stinky. Anyways, it's a base, and it is just doesn't really look like those other bases.